This is my y2. So you do it this way. Are we getting it? Now this is y2, this is y1, sorry. This should be y1, this should be y2. Now, my 2 points of x-axis is what? x2, x1. Now, what do I do? You now subtract. Shall you get? Point 3 is what? Divide, or let's just do it this way. This is the third thing you do. Bring out, you now like subtract y2 minus y1 all over x2 minus x1. This is just what we call slope. Very easy, very straightforward. You just locate the 2 points on the what? Y-axis. You understand? The x-axis, locate your 2 points. Mind you, what makes this y2? This y2 is actually gotten, we transfer to what? Increment. You can see that this y2 on this scale is higher than this y1. That's why this is called y2. And if your y1 is, the value here is higher than this, you won't call this y1, you call it y2. So the higher the value, the higher the subscript numbers given. So by the time you bring that down, y2 minus y1 all over x2 minus x1 will definitely give you a slope. So that's just how to calculate your slope, irrespective of the graph. Now, that is for positive slope. The value of the slope here will definitely give you a positive. Now, for a negative slope, what do you have? You have something like this. As you can see, it goes this way. Remember, this is my y2. This is my y1, right? Now, if we bring this down, this is my x2, this is my x1. Right? Now, for your slope here will now be minus y2 minus y1 all over x2 minus x1. You might not include this minus, but by the time you are actually calculating your value, you definitely result to a minus value. Now, but if you don't actually get a minus value, then you are lucky. But this particular type of slope is always giving a negative sign. Why this gives you the positive slope. Are we getting it now? So automatically we have what? Dealt with slope as it may be. So later we'll now be going to the calculative aspect. Now let's proceed. How do we calculate slope? How do you bring in the calculative aspect now? Let's look at the position versus time. Position versus time now. The two positions are given now from the slide. You look at a car. It runs at 5 seconds. It runs within 5 seconds, covering 10 meters and in terms of position. So as you can see, it should visualizing a triangle with the slope as the what? Hypotenuse. Now the rise is equal to the height of the what? Triangle. Now the run is equal to the length along the base of the what? Triangle. So as you can see, what they're actually trying to establish there is that for slope to be gotten from that graph, you still use this same principle which has been what? Broken down here. Let me draw the graph so that you understand it perfectly. You have your graph, the big one this time. Now you have the diagonal line drawn upward. Now you have something like this. Mind you, this axis is for what? Your position in meters. Why this axis is your what? It's for your time in seconds. Now this junction now, the time is increasing. This is 0. No. This is 5. And this is 10. As the time is increasing, the body is what? Moving upward. You have your car A. This is a car moving upward like this. Are we getting it now? Now, as the car is moving, it has eventually covered 10 meters. You understand? Now it goes upward. Now the run time at which is actually using to is what? 5 seconds. Now, it's so obvious here now that for you to calculate your slope, what do you do? Remember I said your y-axis, subtract your y-axis. If this is 0.0, now to this point is what? 10. From here to here is 0 to 5. What do you do? Slope equals, what will be your y2? Just say y2 minus y1 over x2 minus x1. y2 is what? The highest, which is 10. y1 is what? 0. x2 is what? What is here? 5. x1 is what? 0. So from here you have 10 over 5. So your slope is 2. Slope has no units. Why? Because the values here are measured in meters. The values here, okay, there might be units. There might be units. It will not have units when the two values, you understand, the two properties being plotted against are having the same sign. Please note that these all are not having the same unit. This is unit meter, and this is the unit what? Second. So this unit here is meter per second. So definitely your slope here is what? Speed, meter per second. Are we getting it now? So the speed is to be covered from this point to this point will give you what? 2 meters. 2 meters per second. Note, I'm not saying slope is speed. Are we getting it? I'm not saying slope is speed. But in the case where by the time you get your slope from a given graph and the unit given to you is in mass against seconds, that's m, meters, sorry, I didn't say, sorry, I beg your pardon, I said mass. This is what? Meters. This is what? Seconds. So it will be meter per second. So what do you have as meter per second is physics, and that is what? Speed. So it means that the speed used by that car from this point to this point is what? 2 meters per second. So that settles that. Let's move on. As you can see, it's being calculated there, 2 meters per second. So the slope of what? Position versus time is the what? Speed. That's the conclusion. The slope of the position with respect to time is always a speed. But the slope of what? 2 parameters being drawn together, if those 2 parameters are using the same SI unit, that slope has no unit. Because at this junction, let's say this one is meters now, the 2 meters will cancel out. So slope will not have unit. So let's move on. You can see there is another graph there which speaks about speed versus time graph. It's also the same analogy. So we said of the value being obtained there, the graph which I drew initially talks about distance per time. I said when you are looking for a slope with respect to distance per time, the slope of that particular 2 parameters is actually the speed. Now let's look at some other scenario. Now when you have 2 athletes running together, now from your graph, from your slide, you realize that 2 stubs are actually drawn there. One is drawn this way. Now this is graph A. This is graph B. Please be very much attentive. I'll be very much observant to as regards what I'm drawing. Now this is position M. This is position, this is T, time T, which translates to seconds. This particular body, now if you look at it properly, it means that this particular body B is actually on a high speed compared to what? Point A. What do I mean by on a high speed? It's actually increasing in speed. You see, A is increasing in distance. Are you getting it? A is increasing in distance with respect to time. But B is also what? Increasing in time. You understand? It's wasting time against A. So meaning that A and B are in relative motion with each other. What do I mean? If, let's say peradventure, you have something like this. Let me change the location. I want both to what? Strike the same point. Now this is time T. This is A now, and this is B. Are we getting it now? Now, it means that A here, at a particular time, let's say at 5 seconds, if both A and B are running, if I will ask you, with this graph here, which one of them is actually what? Ahead of each other? Ahead of the other. Which one? If you look at it properly, A is higher. If you look at it in distance, it means that A is what? Far more higher than what? B, in terms of their distance of what? Location. At the same time, they started at the same time, let's say time 0. Now, at 5 minutes, let me use minutes here, not seconds. Immediately after 5 minutes, where are both of them? If I will ask you, are they in the same position? The answer is no. Why? Because this is position B. Position B is, let's say, maybe 5 meters. But this is position A, it's at 10 meters. But they both use the same time. Are we getting it now? So it means that A is ahead of B. Now, if A is ahead of B, definitely A is what? On a higher speed than B. Are we seeing it now? So let me just write it there. A. So at this particular analysis now, A is ahead. A is ahead of what? Of B. Why? Because A is what? Covering higher distance I'm writing this so that you'll be able to get the true gist, higher distance than what? Than B. Even at what? At same time. You can see they are both managing the same time, but A is higher. But look at the second scenario. At the second scenario, B is downward, while A is upward. Now this is A, this is B. At a particular time, this is 5. Let me say, let's use 10 here, 10 minutes. Now, this is still the same, no, not distance this time, speed. In what? In meter per second. Now, this is time, not 10 minutes, 10 minutes. This is time in respect to what? I mean, in minutes. Now, if you look at it properly, what can you deduce here? You should be able to deduce here that, okay, A is ahead. So it means that A is running with a constant what? Speed, meaning that it's not increasing in speed like here. A is running at a constant speed, but what? Is higher than B. B too is running at a constant speed, but is a speed lower than A. At a speed lower than A. If A is running at 50 meters per second, B, obviously, you can see is lower, might be running at 40 meters per second. So if they are both, if both are to run in a race, in an athletic race, definitely A will what? Surpasses. I mean A will what? Will win B in the contest. So hope that has what? Broken down. I mean giving us another what? Idea as regards speed and time. Let's look at something else. Now the graph which have been drawn, which have been drawn initially still says